Hello, my name is Luke Cronin, and today I'll be doing part 5 of my ECE 5000 design project, which is the finished product in Brochure. To begin, I'm going to do a quick walkthrough of the brochure that was created for my Bluetooth controlled garage door opener. So on the first page, I have some pictures of the device along with the application GUI that goes along with the device. I listed some features, so the Bluetooth connectivity, the mobile application, push button, and the rest are listed there as well. I give a brief description of the application that goes along with the device. And then on the left here, I go over various uh, things that go with the device. So the components, the connection, how it's controlled. And then on the next page on the left, you see I have some video support, so you can click on this link to go directly to the video that goes with this submission. Rugged design, I talk about the enclosure, and I also talk about the compatibility. Also, you can see here, I talk about some specifications of the device. So I have the electrical and mechanical specifications. So I have some things like the max voltage, max current, the power rating, the LED indicator status, the yearly energy cost from running the device, which was calculated at 13 cents per kilowatt hour, and assuming that the device is plugged in for the entire year. I talk about the screw terminal sizes. The mechanical, I talk about the operating temperature, the enclosure type, the weight, the dimensions, how it's actually mounted to the wall, the finish, the screw sizes that go with the device, and the operating temperature, which from some trials has just been determined to be the room temperature since the device doesn't heat up very much. Then lastly, I include a device drawing which indicates the screw terminals on how you'd actually connect this to your motor. And I also talk about the connection details in this section right here on the first page. So this this brochure can be viewed with the submission and includes all the necessary information that was required.
So I just want to go over some changes that have been made since the last video. So in the last video, I said that my plans to complete the project would be to improve the wire management within the enclosure or to design a PCB. So for this, I decided to improve the wire management. So as you can see, I have shortened up some connections, and I've also used zip ties to make the enclosure far less messy with wires. So I zip tied the wires for each specific component together. So here's the wires for the relay module, and then I have down here tucked away the wires zip tied together for the Bluetooth module. And then I also shortened up and improved the connections of the LED and the push button. And as you can see with the push button, I did use some hot glue. And the reason for this is that I found that sometimes the small leads on the push button would touch together if they were bent or anything. So I decided to use some hot glue to kind of keep them in place and insulate the exposed pins on the push button. And since doing this, I haven't found any issues with if the device is jostled around, then the push buttons won't accidentally touch or become bent or anything. So now I will once again give a full working overview of the device. So here's the new device with the better cable management. So to install the device, you will want to first take the front cover off, which I already have done. And then there will be two wires that connect directly with your garage door. Nearly all garage door models function in this way, that they have two wires that then connect to the included push button. So you want to remove those from the included push button and then take those wires and just simply insert them into the screw terminals of the Bluetooth module as seen right here. Once that is done, the device is connected to the motor, which is over there. And then you can simply put on the lid and plug it in. So I now have the lid on the device, and it is also mounted to the wall using a adhesive, so tape. And now I will give a very quick demonstration of the device because not much has changed since the last video. So as mentioned, the wires from the garage door are plugged into the device via the screw terminals, and the device is powered using a USB-A to USB-B cable, which then goes into a 10-watt power brick, which is more than enough to power the device, and then it is plugged directly into a wall outlet. This device will most likely be always plugged in, so that's why a wall outlet was used for the power source instead of a battery. Now, to demonstrate the device without using a mobile device, I will show that the open or close button works without it being connected to a device as indicated by the LED not being turned on. So by just pressing this button, you can see and hear the garage door open. Pressing it again stops the garage door, and then pressing again will close it. And also, you may be able to hear the relay closing. Now I will connect a mobile device to our garage door opener. So we'll go to our Bluetooth options on our phone, select HC-06, enter the pin, which is 1234. Wait for that to pair. Once it is paired, we will go to our garage door app, which is right here. We will go into that. We will connect to our specific garage door in case you have more than one. In this case, I only have one, so I'll connect to HC-06. We'll see the user interface change. We'll see the connected button change and the disconnect button change. And then we will press open or close to open or close the garage door. And you will now notice that the Bluetooth LED has illuminated, indicating that we do have successful connection. So pressing open opens the garage door, pressing close again stops, and pressing the button again will retract the garage door. Now if we did want to disconnect, I will show that. We press disconnect, the user interface change, and the Bluetooth LED turns off. And this device can be left powered on for as long as it may need to be, as it can always just be operated by pressing the open or close garage door like the manufacturer garage door button would function.
This is the final code for the device. Fundamentally, nothing has changed since the last submission, except a few comments have been added just for better readability of the code. So just a quick run through since not much has changed at all. Start by defining the pins, then the inputs and outputs. Then we enter the loop, so we check to see if the button has been pressed at all, which is for manual control of the device, so when it's not connected to Bluetooth. If it is, then we trigger the relay to go high, which turns the garage door motor on to either open or close the door. Then we move into the Bluetooth code, which uses the serial on the Arduino. So your mobile device will send either a 1, 3, or 4. So the 1, if the Arduino receives a 1, then that triggers the relay to open and close for that short pulse, which triggers the motion of the garage door. And then if the mobile device sends a 3 or 4, that is what actually indicates the successful connection to Bluetooth, which turns on the Bluetooth indicator LED, which was shown in the demonstration video. Now I will run through how the application was made to actually control the device. So again, I was using MIT App Inventor, which is a mobile app development environment. So we're using a list picker, a button, then I use an image which shows the user how to actually connect the device. Another button which is the disconnect, and then I'm using the Bluetooth client, which is what actually allows your mobile device to connect to the HC-06 Bluetooth module. So here's the user interface, and now I'll just move into the blocks, which is how the app actually works. So we have the list picker. So when you press the list picker, you can see all the Bluetooth addresses and names that your mobile device is actually paired with. This was again chosen so you could control multiple garage door openers if you did have more than one. Next, we move in to the selection. So after you select which garage door you want to control with the app, we actually call the Bluetooth to connect to the HC-06. If there is a successful connection, we change that button to say connected, and we change the color to green. So previously it was blue or turquoise, and then we change it to green to indicate to the user that there is a successful connection. Then we change the disconnect button to turn red, which also indicates that that button can now be pressed. If you do press the disconnect button before there is a connection, the user will be prompted with an error. Then, as I just mentioned in the code section of the Arduino, we will send a 3 through serial, which will then indicate that there's a successful connection and turn on the Bluetooth indicator LED on the device itself. Next, very simple, when the open or close button is pressed, which is button 1, we will send a 1 through serial, which will trigger the relay to open and close, sending that short pulse to activate the garage door motor. Then, if you click the disconnect button, we'll send a 4, which will indicate to the Arduino that there is no longer a Bluetooth connection, and we will turn off the Bluetooth indicator LED. We will call the client to disconnect. Then we will set the buttons back to the default. So we'll set it back to connect device. We'll set the color back to blue or turquoise. And we'll set the disconnect button back to gray. And again, by default, if this disconnect button is pressed, the user will now be prompted with an error. So as I mentioned in the previous submission, to finish this device completely, I was either going to improve the cable management inside the bigger enclosure, or I would design a PCB to eliminate most of the cables and also reduce the size of the overall device. So as you've seen in the previous clip, I did improve the cable management within the big enclosure, but I also did design a PCB, but unfortunately it is taking some time to arrive, but it will be here before the part 6 submission, so I'll show that in the next video. In the meantime, I have some CAD models done to show exactly how the device will look. I already have the enclosure printed. All the components for the PCB itself are received, so I'm just waiting on the board itself. So here is the updated package, and it has the Arduino with the shield already on it, so, or inside it, sorry. So now I'll just show what it actually looks like. So here is what the shield, which is the green board, will look like mounted to an Arduino Uno. And as you can see, it just fits on the top there, and it eliminates most of the wires. The only wires that are needed are obviously the one to connect to the motor and the one to connect to the push button and LED, since those are actually going to be mounted within the enclosure. But everything else, such as the relay here, the Bluetooth module, just fits nicely into the shield, and then the shield connects directly into the pins of the Arduino. In the next clip, I'll do a quick overview of the KiCad schematic and 3D model in KiCad that was used to make this shield. So here is the device schematic for the shield in KiCad. As I mentioned, the device functions the exact same way, just in the smaller form factor. So we have the Bluetooth module here, so exact same. We have the voltage divider to step down the voltage going into the Bluetooth module. We have the RX pin and the ground and 5 volts. And the relay, as I shown in the last video, I just implemented that circuit I showed in the last video with the NPN transistor, the diode, the resistor. So this relay functions the exact same, just in a smaller form factor. And then we simply just have the push button and LED circuits. So very simple schematic here. And then up here, I just have the necessary pins for the Arduino. Now I'll show the routing for the PCB itself. So here is the PCB routing for the Arduino Shield. So in SolidWorks you can't see the traces itself, but in the next clip I will show the KiCad model so you can see exactly what the board will look like. So I tried to organize everything in kind of a symmetric way, and the routing may not be the nicest, but it passes all design rule checks, so this device should work once this board arrives, and it will, as I mentioned again, it'll function the exact same. And here is the KiCad 3D model for the Arduino Shield. With this model you can see all the traces and the silk screen and get a better look at the components. So this should be exactly what the fully assembled PCB will look like. And it is also important to note that this design is what was included in the brochure, as this will be the final design since it is much smaller. It eliminates most of the wires, as I mentioned, by using the PCB obviously, and the wires can be contained in these traces. And it should just overall make the design more rugged and not break as easy by wires coming loose, wires fraying. And I'm looking forward to showing it in my next video. Thank you.